Welcome to the deep dive. This is crafted for number theory students just like you. Today, our mission, let's say, is pretty focused. We're going to unravel, or try to unravel, some secrets in a specific integer sequence from the OEIS, that's A000304. And we'll be using the official OEIS page, plus, it's referenced research as our guide. Okay, so let's unpack this one. OEIS sequence A000304 is defined by the recurrence relation an1 times an2.
Right, and what's immediately captivating about this sequence, A000304, is just how simple that looks. Isn't it? It's a multiplicative version of recurrence patterns we see all over number theory. The OEIS page lists it, starting with an offset of 2, I believe. So A2 is 2, and then A3 is 3.
Okay, A2, A3, 3. And then the definition kicks in an1, an2. So that gives us, let's see, 2, 3, then 2 times 3 is 6.
Exactly. Then 3 times 6 is 18.
Right, 18, then 6 times 18, 108.
108, yes.
Yeah.
And then 18 times 108, that's 1944.
Wow, okay. 1944, you can really see it gets big fast.
It really does. And the next term jumps way up. 108 times 1944 is 209952.
200,000 already. That rapid growth itself is pretty fascinating, isn't it?
Definitely. Just a few steps in, and the numbers are huge.
But okay, while that scale is impressive, the real sort of deep dive here starts when we look beyond just the size, right? What else is going on?
Precisely. Because what makes A000304 really compelling, especially for, someone studying number theory, is how that simple multiplicative rule, it actually breaks down. It can be expressed using something quite intricate and, well, deeply connected to other areas. There's an explicit formula. For n greater than or equal to 4, it turns out an equals 2 raised to the power of A00000045 and is 3. Multiplied by 3 raised to the power of A000004. That's the Fibonacci sequence.
That's the one, the classic Fibonacci numbers, 1, 1, 2, 3, 5, and so on, though we usually start F00, F1. Here, the index is shifted slightly.
So you're saying this multiplicative sequence, an, an1, an2, is actually built using Fibonacci numbers as exponents.
That's exactly right. That is truly remarkable. It feels like finding some hidden code, almost. Fibonacci numbers are usually defined additively, Fn, Fn1 plus Fn2. How do they end up governing a multiplicative sequence like this? It seems counterintuitive.
It does, doesn't it? But it's a beautiful testament to how interconnected mathematics really is. It's not just some fluke. It shows how these different families of numbers, additive and multiplicative structures, can be fundamentally linked. We can maybe check a small term just to see it work.
Yeah, let's do that. How about A4? We know A4 is 6 because it's A2, A3, port 2.
Okay, so using the formula for N4, A4 equals 2A00000045. That simplifies to 2A00000002. Now, A00000004. Now, A000004 is 2 is 0 is equal to 2. Now, A000045 is Fibonacci. F1 is 1, and F2 is also 1, using the F1, F2, 1 start. So it becomes 21 times 31.
Which is 2 times 3 equals 6.
Exactly. It matches perfectly.
That really clarifies it. Seeing the Fibonacci numbers F1 and F2 pop up as exponents to give us the correct term at 4, 6, it really drives home how they're shaping the sequence.
And this formula holds as you go further up the sequence as well.
And the OEIS page itself, I imagine, reflects this, with cross-references.
Oh, absolutely. It's rich with connections. It points to Fibonacci, of course, but also other related sequences. It really illustrates how A000304 isn't just some isolated curiosity. It's like a node in this huge, beautiful network of integer sequences.
Right. It really highlights how applying, fundamental number theory tools can uncover these unexpected structures.
Exactly. A000304 serves as, well, a brilliant example. You start with a simple multiplication rule, and you find it can be explicitly defined using exponents derived from a famous additive sequence. It reveals that deep interconnectedness under the surface.
So thinking about the bigger picture then, for us navigating this, vast world of sequences, what's the key takeaway from this deep dive?
I think the core insight is seeing how simplicity can hide elegance and connection. A000304 shows that a straightforward multiplicative recurrence can unpack into an explicit form, linking it directly to something fundamental, like the Fibonacci sequence. It underscores the interconnectedness in number theory. It shows that sometimes the simplest rules, the ones that look almost trivial, they can lead to really elegant and surprising mathematical relationships.
That's a great summary. It leaves us with something to think about, too.
Yes, exactly. And perhaps this raises a question for you, the listener, to ponder. Given how elegant this explicit form for A000304 turned out to be, involving Fibonacci numbers, what other integer sequences out there, maybe ones that look really complex or chaotic on the surface, might also hold a similar secret? Could they reveal themselves as perhaps products or other combinations involving well-known elementary sequences? It's something to keep an eye out for.